Subscribe to my channel and press the bell icon for latest notification about my videos.
Welcome to all of you. Today our topic is capacitance. So what is capacitance? What are the different approaches to find capacitance? And everything related to that will be discussed in this video. So let's start. The first topic over here is the very first approach to find the capacitance. So for that, what is a capacitor? A capacitor is a combination of two conductors. Suppose this to be a conductor and this to be another conductor. So if these two conductors are placed in such a difference between them, with any medium between them and a certain distance apart, then these two conductors will be able to store energy in a very small space. As we see, these two conductors are very small in size as compared to the ability of them to store charges, so that we call them as capacitors. Now the basic property of a capacitor is to store charges in parallel tangential lines. Okay, as we see that capacitance cannot be like this, it cannot be like this, it should always be something like this. It may curve, it may rotate, everything, but it will not be anti-parallel or it will not be non-parallel lines. So for that, the first approach to find the capacitance of any conductor is simply by taking out the potential difference between the two lines of the hollow conductor. If this to be a cylindrical capacitor with a dielectric constant K between the two cylinders, then the potential difference of them will be determined, and after determination of this potential difference we can find out the capacitance as C is equals to Q by V, where V will be the potential difference of these two cylinders and Q will be lambda into L, that is charge per unit length. Lambda is equals to Q by L, that is charge per unit length. So we are getting the two basic constituents of this capacitance approach. Now for this we will be finding out the capacitance of a hollow cylindrical conductor with the inner cylinder as radius A and the outer to be B, and a dielectric constant K in between them, and the length of the cylinder is L, and this to be the axis. Suppose this to be A to A dash, suppose. Okay, now we will be following our first and fundamental approach of taking out the capacitance with the voltage formula. So first we will be doing that. If we can find out the charge as lambda into L, and if we can find out V with in terms of electric field intensity or electric field, then it will be very easy for us to find out the capacitance as equals to Q by V. So we will be finding out the electric field. Now for finding out the electric field, we know from the previous lectures that we have seen that according to Gauss's law, this phi E or electric flux to say is equals to closed integration of E dot ds to get in vector form. Now if we see a cylinder like this, okay, a plain cylinder, we see that the surface of the cylinder are in the normal 180-degree plane lines. It is having cylinder distance L, suppose this distance to be L, and the surface area of this cylinder to be ds. Okay, now this ds constitutes the single layer of this L. If this is multiplied by L, the entire surface of this total surface of this cylinder will be got. Now we see that this electric field lines coming out from this cylinder will be circular lines coming from this center line. Okay, supposingly as like this or something like this, will be coming like this. So for that purpose, the angle between this electric field lines and the coaxial or the axis of the cylinder is totally 0 degree, as they are in the same plane. So the angle between them written as close integration E vector dot ds into cos of 0 degree. This is equals to 1, so this will be ds. Now this E vector is written as cos, so this vector sign will be removed, and this E is a constant quantity, so it will come out of the integration. There is E will come out, and this will be equals to ds. Now this ds is closed integration of ds equals to 2 pi r. This is the total surface area of this circle into the length of the total cylinder. So it will be equals to E into 2 pi RL. Now we have got the flux over here, and we know that according to Gauss's theorem, this electric flux is equals to total charge inside the fluxing area divided by epsilon naught into K, where K is the dielectric constant. So we can write this as E into 2 pi RL is equals to Q in, that is Q is equals to lambda into L divided by epsilon naught into K, as a medium is present between the two hollow cylinders. So we can write it as L, and L will get cancelled. This E equals to lambda by epsilon naught into K dot 2 pi R, or to modify it, we will be writing this as lambda by 2 pi epsilon naught K into R. So this will be the electric field intensity of the cylindrical capacitor at any particular point. Now if we give a unit positive test charge to this inner cylinder, what will happen? As this is a conductor, we'll be seeing that if we give a unit positive test charge over here, this charge will be induced as an equal amount of negative charge on the inner layer of this outer cylinder. So this equal amount of positive charge will be induced on the outer surface, extreme outer surface, as plus. Now if we earthen this surface, what will happen? This plus charge will directly go to the earth, as earth is a very good acceptor of positive charge. So this plus charge will get transferred to the earth. So this will be simply as positive and negative. Now if this is a conductor, then we know according to basic laws of physics that there will be numerous amount of positive charges inside the walls. So it will be plus, 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 and this will be minus, 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 infinity, as is conductor. So we are getting a potential over here and a potential over here. So easily we can take out the potential difference between them. Now according to the Coulomb's law and its derivatives, we know that this potential difference V is equals to negative integral of E dot dr, where E is the electric field intensity at that point, and this dr is the distance from the charge where it was previously located and the present point. So we can see that this E is equals to lambda by 2 pi epsilon into K, which we term as equation number 1. If we put this value over here, we are getting that this is equals to negative integral of lambda by 2 pi epsilon naught into K into R dot dr. This is entirely a constant quantity, so it will come out of the integration, and this will be equals to negative integral negative lambda by 2 pi epsilon naught K, and this will be inside the integral 1 by R dot dr. Now we have given the charge to the surface A. Okay, surface A, and this is surface B. So we are doing the work from giving the charge from outer surface to inner surface. So the limit of this integral will be from b to a, that is from small b to small a. This will also be equals to small b from small a. So this will be turning out to be minus lambda by 2 pi epsilon naught k into ln r from b to a. So we can write it as is negative sign over here. So we can write it as ln b minus ln a as negative sign is present. I repeat, if negative sign was not present over here, then we have written simply it as ln a minus ln b. But if we substitute the value of this negative sign inside the bracket, we're getting it as ln a minus ln b. Here an entire minus, so ln b minus ln a. So this will be equals to lambda by 2 pi epsilon naught into k into ln b by a, as the property of log states that ln b minus ln a is equals to ln b by a. So we have got the potential difference over here also. So we know that capacitance is equals to C is equals to Q by V, where Q is equals to lambda L and this V is equals to achieved value is lambda divided by 2 pi epsilon naught into K, and here it is ln into B by A. So we'll be getting this as lambda will get cancelled. This will be shifting over up, that is 2 pi epsilon naught into K into L divided by ln B by A. So we have finally achieved, after a long process, the capacitance of the cylindrical hollow capacitor. So the approach of us got successful. So what was the previous approach of us? It is taking out the potential difference by any mean, and then finally putting this value of potential difference as Q by V and taking the capacitor. This process can be followed for any kind of capacitor. It may be a cylindrical capacitor, it may be a spherical capacitor, it may be a parallel plate capacitor. So that's all for this video. Please like, share and subscribe and keep watching.